card questions. So the first question is that event A, event E is 7, 8, queen and ace. How many times a favorable event can happen? So probability of favorable event would be number of ways this can happen, which is there are 4 cards, 4 ranks and 4 suites, so that is 4 times 4, that is equal to 16. And what is the total sample space, which will be 52, so that is going to be 4 by 13. Second question is, if it is known that we have a picture card, if we know that it is a picture card, so we have a known information, that is K1, that it is a picture card. Now we want to know the probability of E, knowing that we have a picture card. Now picture card is only queen, so then there are 4 queens, so that would be a total possible way event can be 4, and the among the 4 desirable events, there are only 4. But how many picture cards are there? Picture card is queen, jack and king, so 3 of each suite, and there are 4 suites, so there would be 12. So 4 out of 12, or 1 by 3. Now option number 3 is, what if we know that it is 6 or 7? Now if it is 6 or 7, then probability of favorable event, knowing K2, is how many times we can have 6 and 7. There are only 1 7, so it is 7 times 4, that would be 4. And since we know it's only going to be 6 or 7, the total sample space is going to be 4 out of 4 times 2, that is 8, or 1 out of 2. Now what if we know that K3 is not 3, 4, 7, 9 or 10? So NK3 is going to be 52 minus 20, because these are 5 cards. 5 times 4 will be 20, so that is going to be 32. 32 is our sample space, and E and K3 is going to be how many ways the event can happen when you don't have these cards. So obviously 7 is not possible, so only 3 is possible. So only 8, queen, 8 queen and ace is possible out of 4, so that's going to make it 4 times 3, or 12, and the sample space is 32. So that is that, because it is probability of event, knowing K based on the Bayes equation, we know it's going to be E and K divided by K. Okay, further card question is a different question, which is probability of drawing 1 ace upon drawing two cards from a deck. The easier way of doing this is by combinatorial way, which is the possible way you can draw two cards from a deck of 52 cards will be 52 choose 2, and the first card is ace and there are 4 ace, so you will draw 4 times, so 4 choose 1, and then the left is 48 from which you're going to choose 1. There is another way of coming up with the same number, which is a probability of only one ace in the first card, but it's more complex, so we'll limit to the combinatorial way of doing this, drawing one ace upon drawing two cards. Now this can be asked in a different way, which is two cards from two cards are picked randomly from a deck. Chances that both are ace given that either is an ace. So what is the probability of first card being an ace? This is going to be 4 out of 52. And what is the probability of the second card being an ace? Is because we're only left with 3, and 3 out of 51. That both are ace given that either one is an ace. So one card is an ace and this is that one, and then the other one's probability is 3 out of 51. But this is when we are picking the two cards together. If we are picking the two cards sequentially, if picking sequentially without replacement, then we can just work with the reduced sample space, which mean that the first card you draw as ace, the chances are 1 out of 52 or 4 out of 52, but the second card you draw, which is going to be an ace, is going to be 3 out of 51 or 1 out of 17. It is just you're working with the reduced sample space. Now if you ask a question that what if either is ace of spade, so it's really asking just the same thing, probability of the second card being an ace if either is ace of spade. Probability of one card, it is probability of one card being an ace of spade, which is just 1 out of 52 times probability of second card being an ace, which is going to be, because one ace is chosen, which is going to be 3 out of 51. So it is different here from here. This one is 4 out of 52 and this one is 1 out of 52, because this is, we are choosing either is an ace whose possibility becomes 4, while we are choosing ace of spade whose possibility becomes 1 out of 14. So moving on to other questions. Draw one card from 52. What is the chance that I did not pick a face card? What is chance that I did not pick a face card? So face cards probability is 3 times 4, that is 12. Chance of picking a face card is 12 by 52. Not picking is going to be 1 divided by 12 by 52, or 10 over 13. Other question is, pick 2 cards one at a time. First card is a king. Probability of second card also being a king is just going to be from a reduced sample space, because now only 51 card is left and 3 kings are left. That's going to be 3 out of 51. Question: what is the probability that you draw 4 aces from a deck of 52 cards? So probability of 4 aces is just going to be event, which is 4 aces divided by sample space 52, choose 4. So event is only 1. Now you can have 52 choose 4 combinations of cards if you choose 4, and out of them only 1 is 4 aces. So it basically becomes 1 divided by 52 choose 4. This can also be written the way we have been doing with the reduced sample space, which is 4 out of 52. Then the next possibility is 3 out of 51. Then the next possibility is 2 out of 50. Then 1 out of 49, which will give the same result. But if the question is that we are doing it with replacement, then the probability will become 4 over 52 times 4. Here we are picking 4 at the same time, but here we are picking at random. The other question is, draw 2 cards out of 52. What is the probability that the second draw will be king if first was not a king? So if sequentially we are drawing, then we just work with the reduced sample space, because the first we have drawn already and it was not. So we still have the 4 kings remaining, and then it is 51. But if we are drawing it together, then this question is very much similar to the aces question, which is the probability of getting at least 1 king. Okay, the next question is a deck of 52 cards. You draw 2 cards without replacement. Probability of both cards being red, knowing that one is red. Now how many total 2 card draws are there? That is going to be 52 choose 2. That is 300, 1326. Out of them, how many 2 black draws you can do? 2 black draws we can do is 26 choose 2. That is going to be 325. We have to remove this from our sample space. So 1326 minus 325, that is going to be 1001. Because we know that one of them is red, so the possibility of 2 black draws is this much. 26 choose 2. So the only 1001 are left not which are not two black, because this is the total combinations you can get. You can get a red and a red, and a red and a black, and a black and a red, and a black and a black. We know that at least one is red, so we only have to work with this group. We don't have to work with this group at all, so this we excluded, and the total combinations of this is going to be 1001. Now, how many two red draws are possible? The two red draws are also going to be 26 choose 2, that is going to be 325. So this is also 325. So this is going to be 325 divided by 1001, that is 25/77.